What if humanity's next home isn't the red world we've been dreaming of, but a frozen moon wrapped in golden mist? Welcome back, traveler. Tonight, we drift through science. Picture a distant shoreline under an orange sky, where methane waves rise and fall in slow, glassy rhythms, and Saturn hangs overhead like a silent guardian. In that place, every breath of wind carries secrets from a world completely unlike our own. On quiet nights like this, it feels natural to wonder how far human life could spread across the solar system. You are here, safe and unhurried, listening as the dark outside settles into a soft stillness. The weight of the day loosens its grip, and your attention drifts upward, to worlds that glow faintly in the cold outer regions, waiting patiently for someone to understand them. Tonight, that wandering mind becomes your vessel, guiding you toward a question that feels both strange and strangely comforting. Titan and Mars could not be more different. One is dusty, dry and familiar in color, an empty desert that resembles Earth's bones. The other is dense with atmosphere, wrapped in haze, rich in organic molecules, and shaped by alien chemistry. Comparing them touches something deeper than exploration. It reveals what we believe life truly needs. Some scientists, from NASA to ESA to Caltech, argue that Titan may actually offer more long-term potential than Mars, not because it is easier, but because it is stable, protective, and full of building blocks. That possibility reshapes our place in the solar system. Before we wander through these frozen valleys and amber skies, there's something simple you can do to help this quiet journey reach others. If these calm explorations bring you peace, insight, or just a gentle moment at the end of your day, leaving a like and subscribing to the channel helps new travelers discover this quiet corner of the universe. Every small gesture expands this constellation of listeners, one sleepy soul at a time. And now, as the night deepens and your mind settles into a steady rhythm, let's follow the trail of light that leads from Earth to Saturn's largest moon. Ahead lies an unexpected possibility, one that challenges everything we thought we knew about habitable worlds. Let's drift toward it together. There's a calm clarity that settles in when you think about humanity's next possible home. The solar system feels enormous, yet two worlds stand out like competing invitations. Mars, with its familiar, dusty plains, and Titan, Saturn's enigmatic moon wrapped in thick, swirling haze. Both whisper promises of shelter, discovery, and destiny. But their personalities couldn't be more different, one sharply exposed, the other cocooned in a protective atmosphere that softens sunlight into shades of gold. This first comparison opens the doorway to a profound question. What kind of world truly nurtures life? Scientifically, the differences begin with something simple: temperature and exposure. Mars sits much closer to the sun, but with almost no atmosphere to slow the escape of heat, it remains relentlessly cold. Titan, though vastly more distant, maintains steady surface conditions thanks to its dense atmosphere. Roughly 1.5 times the pressure of Earth's, Mars greets travelers with radiation and rawness. Titan greets them with shielding and stability. This contrast shapes nearly everything about what humans can realistically expect when stepping onto either surface. Floating through Titan's atmosphere feels like drifting inside a dream. The light becomes soft, muted, almost cinematic, filtered through haze rich in hydrocarbons. Shadows lengthen in peculiar ways, and the world glows with a perpetual twilight. The air is so thick that human wingsuits, in theory, could allow you to glide. Meanwhile, Mars offers a stark silence under a pale pink sky, where dust devils twist slowly, leaving thin scars on an ancient landscape. Titan soothes, Mars exposes. These sensory differences influence every piece of future human imagination. Such contrasts force deeper reflection on what we truly value in a second home. Is humanity seeking raw frontier challenge, the rugged test of survival on Mars? Or do we secretly long for a world that feels gentler, quieter, more patient? Titan's shielded environment suggests a kindness that Mars simply doesn't offer. Yet Mars, harsh as it is, mirrors Earth more closely in composition and chemistry. Deciding between them becomes a reflection of humanity's desires. Do we chase familiarity, or do we embrace alien beauty? At a broad level, both worlds demand immense technological commitment. Mars challenges us with its thin air, lack of oxygen, and dangerous radiation. Titan challenges us with cryogenic temperatures so low that water behaves like rock and methane behaves like rain. Yet beneath these differences lies a striking similarity. Both worlds provide enormous scientific and cultural meaning simply by existing as potential homes. The comparison inspires engineers, scientists, writers, and dreamers alike, pulling human ambition outward. The physics of each world's environment shape everything about survival strategies. On Mars, the thin atmosphere makes landing spacecraft extremely difficult. Parachutes barely work, and rockets must take over most of the descent. On Titan, by contrast, the thick atmosphere acts as a natural cushion, allowing probes like Huygens to drift down gently. For future colonists, this means equipment behaves very differently depending on which world they choose. Environments sculpt possibilities long before boots touch the ground. Under Titan's amber haze, methane winds carve slow patterns across dunes of frozen organic particles. The landscape resembles Earth's deserts, but operates on entirely different chemistry. Mars, by comparison, presents basalt plains, ancient riverbeds, and the scars of past water flow. One world preserves the memory of water long gone. The other contains rivers and lakes, but made of methane and ethane, not H2O. Both worlds echo Earth while rejecting Earth's rules, revealing a cosmic diversity that humbles the imagination. Thinking about these differences pulls the mind towards something deeper. How adaptable is life itself? Titan's chemistry suggests pathways for exotic biology, life not based on water, but on methane or even complex hydrocarbons. Mars suggests an older story, a world that once held oceans and perhaps microbes, now reduced to a desert where traces of ancient life might remain hidden beneath the dust. Titan looks forward, offering potential. Mars looks backward, offering memory. Together, they form a dialogue about life's versatility. As this dialogue unfolds, the question of environment becomes more than physics. It becomes philosophy. What does it mean to thrive, comfort, or challenge? Titan's thick atmosphere protects residents from radiation and creates a world where colonies could exist with relative safety, albeit extreme cold. Mars exposes residents to constant risks, but offers sunlight, mobility, and landscapes similar enough to Earth to feel familiar. Perhaps humanity needs both kinds of worlds, one to test its endurance, the other to nurture its imagination. Step back and consider the emotional contrast of stepping onto either world. On Mars, the sky would feel fragile, its thin atmosphere unable to muffle the silence. Every breath would depend on sealed habitats and careful engineering. Titan, however, would envelop you in a warm-toned dimness where sound travels differently, carried by dense air. Even though the environment is deadly cold, the sensation of immersion feels more comforting. That psychological difference matters. Colonization depends as much on the human mind as on hardware. NASA's scientific models highlight another key point. Titan's atmosphere acts as a perfect radiation shield. The thick nitrogen and hydrocarbon haze blocks cosmic rays, solar flares, and gamma bursts extremely effectively. Mars, lacking a magnetic field and atmospheric density, exposes settlers to radiation levels far higher than Earth. For long-term living, this becomes one of the largest differences between the two candidates. Radiation shapes not just safety, but agriculture, infrastructure, childhood development, and generational colonization. Imagine walking inside a habitat on Titan, hearing the subtle hum of heaters, lights flickering softly through the fog outside. Beyond the walls, methane lakes ripple under Saturn's glow, and winds brush across frozen dunes. Life there would feel slow, insulated, introspective. Mars, in contrast, demands constant vigilance, storms of dust, radiation spikes, temperature swings. One world encourages contemplation, the other insists on resilience. These psychological atmospheres influence not only survival but culture. For scientists, Titan holds particular fascination because it possesses all the basic ingredients for complex organic chemistry. Huygens' data and Cassini's measurements revealed molecular patterns reminiscent of early Earth, carbon chains, nitriles, and atmospheric processes that resemble primordial soup. Mars, meanwhile, offers geological clues to its wet past: clay minerals, sedimentary layers, and occasional methane spikes that hint at underground processes. Both worlds carry the fingerprints of chemistry that could, under the right conditions, support life. This realization shapes exploration strategies. Mars is targeted for drilling, rock sampling, and potential fossil detection. Titan, by contrast, is targeted for Dragonfly, NASA's nuclear-powered rotorcraft designed to fly from dune to dune, sampling organic-rich terrain. Mars asks, what lived here long ago? Titan asks, what could live here someday or right now in forms we've never imagined? These perspectives complement each other like two halves of humanity's scientific curiosity. Even the composition of each world's surface reflects differing philosophies of habitability. Mars's regolith is dry, oxidized, and chemically reactive, challenging agriculture and habitat construction. Titan's surface is coated in hydrocarbons that could potentially serve as raw materials. Plastics, fuels, and molecules useful for manufacturing. Colonists on Titan might build with chemical resources rather than minerals. Each world offers something that challenges our assumptions about what home means in an extraterrestrial context. Stepping further into Titan's uniqueness, its low gravity, just 14% of Earth's, gives every movement a gentle, bouncing quality. Martian gravity, around 38% of Earth's, feels more natural but still lighter than humans evolved for. Over generations, these differences would reshape human physiology, biomechanics, and daily routines. Titan would feel like moving through soft snowfall. Mars would feel like hiking with unseen springs in your boots. Each world sculpts the human body in its own way. Cultural development on either world would diverge dramatically. Mars colonies might adopt rugged, frontier-like cultures built around resilience, engineering, and communal problem-solving. Titan colonies might evolve quiet, insulated traditions, art shaped by dim light, music influenced by dense air acoustics, stories whispered beneath Saturn's rings. Environmental psychology becomes destiny. Even the silence of each world sounds different. Mars echoes faintly, Titan muffles softly. Over time, the practicality of long-term settlement reveals different strengths. Mars offers sunlight for solar energy, easier access to rock for construction, and temperature ranges that, while harsh, are manageable with current engineering. Titan offers abundant chemical energy, thick atmosphere for aerobraking, and natural shielding from radiation. Both require technology for heating, oxygen production, and pressurized living. Yet the trade-offs create distinct philosophies of survival. Logistics play another subtle role. Mars is relatively close, with travel windows opening every 26 months. Titan sits far beyond, requiring journeys of 7 to 10 years using current propulsion. This distance shapes the commitment required for colonization. Mars feels like an ambitious expedition. Titan feels like a generational investment. The psychological distance matters as much as the physical one. Choosing Titan implies embracing deep isolation and long-term vision. Environmental cycles offer further contrast. Mars has seasons similar to Earth's, though colder and dustier. Titan's seasons move slowly, unfolding over 7-year stretches as Saturn orbits the Sun. Colonists on Titan would live through epochs of weather rather than seasons, each shift measured in years of subtle change. This slow environmental rhythm might encourage patient or introspective culture, like living inside a cosmic clock that ticks only occasionally. Yet Titan's cold remains its greatest challenge. At 170 C, nearly everything freezes. Water becomes stone, metals behave strangely, and materials become brittle. Heating demands enormous engineering solutions. Mars, though cold, is far warmer by comparison. This difference often leads engineers to argue that Mars is simply easier. But ease is not the only measure. Long-term safety, protection, and available resources shift the argument back toward Titan's potential. With each comparison, the question grows more layered. Neither world is perfect. Neither world is easy. Both require rewriting the rules of human existence. But Titan consistently offers something Mars does not: protection. That protective quality makes it feel welcoming, in an alien way, as if the universe carved out one corner where humans could shelter beneath golden clouds while learning to adapt to new chemistry and new physics. This sense of welcome blends into curiosity about what life might already exist there. Titan's lakes and dunes might host exotic organisms unlike anything on Earth. Life not based on water, but on methane, or even on self-organizing hydrocarbons. Mars likely holds fossilized or microscopic remnants. Titan may hold something active, evolving, and alien. That possibility reshapes exploration priorities and ignites a different kind of excitement. And as we step back from both worlds, the comparison becomes less of a competition and more of an invitation. Mars calls to the pioneer in us. Titan calls to the dreamer. Mars offers a rugged mirror of Earth. Titan offers an elegant mystery. Tonight's journey begins by holding both in the same quiet breath, letting their differences settle like stardust in the mind. Ahead lies a deeper exploration of Titan's hidden advantages, the ones that could redefine humanity's future in the cosmos. Mars reveals its nature the moment you imagine standing on its surface. The air barely brushes your skin, almost non-existent, too thin to carry warmth, sound, or comfort. With only 1% of Earth's atmospheric pressure, it feels less like a sky and more like a fragile membrane stretched over a lifeless desert. Every breath requires machinery. Every step exposes you to radiation. Nothing about the atmosphere offers safety. It offers only honesty, an unfiltered reminder that Mars was not shaped with humans in mind. By contrast, Titan envelopes everything with weight and presence. Its atmosphere presses gently, far denser than Earth's, forming a cushion that protects against space's violent radiation. This density allows sound to travel differently, carrying voices in mellow, softened tones. Although the air is unbreathable, mostly nitrogen with methane traces, it behaves as a blanket rather than a threat. Where Mars exposes, Titan shelters. This basic atmospheric difference changes the entire philosophy of colonizing each world. Under Titan's golden sky, sunlight becomes a diffuse glow rather than a direct beam. The thick haze scatters brightness into a constant twilight, giving the landscape a muted, dreamlike quality. Colors dissolve into amber gradients, shadows blur, and horizons feel closer, as if the world itself is wrapped in silk. Mars, on the other hand, sharpens everything. Its thin air creates crisp edges, harsh sunlight, and skies that fade quickly into black. Each planet paints a different emotional experience simply by filtering light. These sensory contrasts raise deeper questions about psychological well-being. Human minds evolved under soft blue skies and stable atmospheric pressure. Titan's thick air, despite its frigid temperatures, offers physical comfort and emotional calm. Mars demands constant alertness, forcing settlers into a mindset of vigilance rather than serenity. Over decades, these atmospheric tones would shape entire cultures, one world encouraging introspection, the other cultivating resilience. Researchers at NASA and ESA emphasize that Titan's atmosphere provides the best natural radiation shielding of any known accessible world in the solar system. Cosmic rays, solar flares, and high-energy particles struggle to penetrate its haze. Mars lacks this luxury. Its thin atmosphere and missing magnetic field allow radiation to bombard the surface freely. For long-term colonization, this difference is monumental. Generations could grow on Titan without encountering lethal exposure levels. Because Titan's atmosphere is so forgiving, spacecraft can descend with remarkable ease. Parachutes work beautifully, drifting gently through dense air. The Huygens probe proved this in 2005, landing softly after a long measured descent. Mars landings, by comparison, are notoriously difficult. Parachutes barely slow the craft, forcing rockets, heat shields, and complex landing sequences. The atmosphere becomes an obstacle rather than a partner. Titan lends its air as a helper. Mars treats it like a puzzle to solve. Walking across Titan's surface would feel strangely immersive. Air resistance would slow your movement slightly, and every step would feel accompanied by soft pressure. Mars delivers the opposite sensation, a near vacuum where every motion feels exposed, where the silence is almost too absolute. These physical sensations help determine how humans emotionally bond with a place. Titan's atmosphere creates comfort through presence. Mars confronts settlers with emptiness. Another key atmospheric difference lies in temperature regulation. Titan's thick air distributes heat more effectively, preventing drastic swings between day and night. Mars lacks that insulation. Temperatures can plunge from mild afternoon cold to deadly nighttime freeze within hours. Stability on Titan offers engineering advantages. Structures face fewer thermal shocks, equipment lasts longer, and habitats maintain consistent temperature more easily. Mars requires constant energy expenditure just to maintain livable interior conditions. Sound behaves differently on Titan as well. The dense atmosphere slows vibrations, creating an acoustically rich environment where voices sound deeper and softer. Machinery hums with velvet edges. Even footsteps might produce a gentle, unpadded tone. Mars delivers near silence, broken only by thin gusts and metallic echoes through pressurized suits. One world feels intimate, the other feels lonely. Colonists would experience daily life through contrasting auditory textures. The thick haze around Titan also serves as a natural shield from micrometeoroids. Small particles burn up or vaporize before reaching the ground. Mars experiences the opposite. Micrometeorites regularly strike the surface, and its thin air barely slows them. Habitats on Titan might require less reinforcement, lowering construction difficulty. Engineering simplicity becomes a powerful advantage when building far from Earth's supply chain. Titan's atmosphere contains complex organic molecules produced through photochemistry. When sunlight interacts with methane and nitrogen, it triggers reactions that form hydrocarbons and nitriles, materials relevant to prebiotic chemistry. Mars lacks this atmospheric creativity. Its thin CO2-dominated air hosts simpler reactions and fewer molecular pathways. Titan's sky behaves almost like a chemical workshop, continuously generating potential building blocks for future research or even exotic life. Over time, colonists might learn to utilize Titan's atmospheric resources directly. Hydrocarbons could be harvested for fuel, plastics, or industrial feedstock. Mars offers CO2 for oxygen production and fuel generation through the Sabatier process, but the atmosphere contains little else. Titan's air becomes both shield and resource. Mars's air remains something to process rather than something to use creatively. The emotional impact of each sky cannot be overstated. Titan's golden dimness creates a slow, contemplative mood reminiscent of late afternoon on Earth, stretched across every hour. Mars's pale skies inspire awe, yet emphasize isolation. On Titan, humans might feel enclosed within a gentle cradle. On Mars, they might feel suspended on the edge of a cosmic void. Both sensations are profound, but only one lends itself to long-term psychological comfort. From a biological perspective, Titan's atmospheric pressure is incredibly convenient. Humans evolved under similar pressure on Earth, and while Titan's is higher, it's close enough to allow easier habitat design. Mars requires insulated and pressurized structures, carefully engineered to avoid catastrophic failure. Titan's pressure is strong enough to support external suits that look more like cold weather gear than space armor. Mars demands full, rigid spacesuits for every excursion. Light availability further differentiates the two worlds. Titan's haze filters sunlight so thoroughly that solar energy becomes nearly useless. Colonists would rely on nuclear power or chemical fuels. Mars receives more direct sunlight, making solar panels more practical. Yet solar storms and dust accumulation still pose major challenges. Both worlds limit solar energy, but for entirely different reasons. Another intriguing factor is atmospheric buoyancy. Titan's thick air supports flight with surprising ease. Balloons, gliders, or even human-powered wingsuits could function in ways impossible on Mars or Earth. Exploration on Titan might unfold from the air as often as from the ground. Mars, by contrast, limits flight severely. Ingenuity's short hops remain engineering miracles in near vacuum. Atmospheric structure determines the style of exploration. Even communication experiences differences. Radio waves behave predictably in Titan's dense medium, allowing reliable ground-to-ground transmission with minimal interference. Mars suffers from dust storms that occasionally interrupt signals. Titan's haze is chemically active, but generally stable. Dust is absent. Operations grow more dependable, and infrastructure becomes easier to maintain. Breathing Titan's atmosphere is impossible without equipment, yet psychologically, the sensation of being enveloped might feel less alien than Mars' thin, hollow air. Humans associate atmospheric presence with safety. Titan mimics that sensation, even if its chemistry is toxic. Mars mimics vacuum more than Earth. This emotional nuance might determine where long-term families are willing to settle. Temperature remains Titan's harshest atmospheric trait. 179 degrees poses severe risks to equipment and human skin, requiring specialized materials. However, the cold also freezes water into structural ice that behaves like rock, potentially aiding construction. Mars, though warmer, still requires significant heating but lacks such abundant structural materials. Atmospheric influence extends even into architecture. Agriculture becomes another story shaped by air. Mars's thin atmosphere cannot trap heat or protect crops from radiation, Greenhouses must be heavily shielded. Titan's dense air blocks radiation effectively, though its cold requires extensive heating. Still, shielding demands on Titan are far lower, making long-term agricultural domes more feasible. Atmospheric chemistry guides the evolution of food production systems. These atmospheric contrasts ultimately reveal each world's character. Mars expresses openness and vulnerability. Titan expresses depth and protection. Mars feels like a challenge sculpted to test humanity's determination. Titan feels like a sanctuary waiting to be warmed. Each atmosphere conveys a message about life, survival, and the type of future humans envision. Choosing between them means choosing between two philosophies of existence. Mars offers a frontier built on grit and exposure. Titan offers a cradle built on chemistry and calm. The atmosphere becomes more than a scientific detail. It becomes the emotional climate of a new civilization. And as these golden clouds and dusty skies drift across your imagination, you begin to sense why Titan has quietly risen in scientific discussions as a contender for our future home. The air itself tells part of the story, and deeper truths wait beneath, guiding us softly toward what comes next. Gravity shapes the way a world greets you. On Titan, your body would feel lighter than ever before, so light that ordinary movement becomes slow and graceful, almost like drifting underwater. Every gesture stretches into something soft and fluid. Steps lift you higher, and balance becomes playful rather than demanding. Mars, however, sits in a middle zone, lighter than Earth, but not enough to make motion feel poetic. Its gravity is practical, utilitarian, slightly freeing, but unmistakably still tied to the ground. Researchers often point out that Titan's gravity allows humans to lift heavy objects with ease, transforming manual labor into something closer to choreography. Construction crews could move large panels, tools, or modules without machinery. Mars requires more conventional support, still demanding effort and equipment for large-scale building. Colonies on Titan might rise like sculptures shaped by human hands, while those on Mars would resemble industrial outposts reliant on robotics and metal frameworks. Lighter gravity also shapes psychology. On Titan, movement itself becomes calming, a slow, floating rhythm that mirrors the thick air and golden light. Many scientists argue that such an environment might naturally reduce stress, offering a meditative quality to everyday tasks. Mars offers freedom of weight, but still forces awareness of risk. Its reduced gravity helps efficiency, but it never removes the underlying tension of a planet that constantly tries to strip heat, moisture, and safety from human life. The buoyancy Titan provides extends beyond the human body. Its atmosphere is dense enough to support flight effortlessly, meaning personal transport might resemble gliders or small, silent airships drifting between settlements. Mars requires loud engines and precise engineering just to lift off the ground. Gravity and atmosphere collaborate differently on each world, determining whether exploration feels like drifting in a dream or hiking across a rugged, open desert. Under Titan's conditions, you could theoretically fly by strapping wings onto your arms. NASA simulations show that a human with a wingspan of 3 meters could glide smoothly thanks to the combination of low gravity and thick atmosphere. That possibility gives Titan a whimsical quality, an echo of childhood fantasies becoming practical realities. Mars cannot offer that sense of play. Instead, it offers challenge and perseverance. Because gravity affects muscle retention and bone density, long-term settlement becomes a biological question. Titan's gentle pull might be too low to sustain human physiology without regular exercise or artificial gravity. Mars presents similar concerns, though slightly less severe. Scientists debate which world would require more frequent intervention. Gravity becomes not just a sensation, but a medical puzzle that defines how future generations evolve. Despite the challenges, Titan's gravity offers unique engineering benefits. Heavy structures exert less stress on foundations, allowing architects to design broader and more creative buildings without worrying about collapse. Towers, domes, and entire cities could rise with less material than on Earth or Mars. Gravity becomes a canvas rather than a constraint, shaping civilization from the ground up. Another intriguing implication comes from surveying terrain. Rovers on Titan can traverse difficult landscapes with extreme stability, as lighter weight reduces the risk of sinking into soft hydrocarbon soils. Mars' chaos with higher gravity and thinner air forces rovers to behave cautiously to avoid tipping or damage. Exploration speed increases on Titan, broadening scientific horizons. Gravity also influences weather patterns. Titan's slow atmospheric flows create large-scale, gentle wind systems that move clouds like drifting curtains. Mars experiences dust storms, accelerating at high speeds, capable of enveloping the entire planet for weeks. One world whispers its weather, the other roars. Colonists would adapt to completely different emotional atmospheres shaped by these dynamics. Thinking about how gravity affects daily chores evokes surprising insights. Carrying resources, maintaining habitats, or traveling long distances would feel smoother on Titan. Mars, though manageable, remains physically demanding. These subtle differences accumulate over years, shaping how people view their adopted world, either as an ally or a constant challenge. Children born on Titan would grow up in a world where jumping feels like flying. Their sense of physical identity would be profoundly different from Earth-born generations. Mars-born children would also experience lighter gravity, but stay grounded enough to develop movement patterns closer to Earth. Each planet would create distinct cultures, influenced by how gravity shapes childhood play. Over time, settlers might develop technologies that mimic Earth's gravity for health reasons. Rotating habitats or exercise centers would appear on both worlds. Yet Titan's low gravity makes launching spacecraft far easier. Achieving escape velocity requires much less energy, transforming Titan into a potential hub for deep space travel and exploration. Mars demands more fuel, more planning, more constraint. The question of emotional resonance arises again when imagining how gravity affects leisure. On Titan, games and sports would adopt graceful aerial qualities, long leaps, slow aerial spins, and cooperative gliding. Mars would encourage high jumps and fast movement, but still anchor players firmly to the surface. Gravity becomes an expression of culture, shaping how humans bond and create community. Scientific teams studying planetary habitability often describe Titan's gravity as gentle but tricky. It helps with construction and energy savings, but complicates biological adaptation. Mars sits in a different category, manageable but harsh, requiring intense radiation shielding and constant pressurization. Gravity itself becomes a symbol of the world's personality. In exploring Titan, the experience might feel like walking through a dream where the body obeys unfamiliar rules. Every step becomes a slow, subtle dance. Mars makes you feel like a pioneer, pushing forward through an environment that demands respect. Both sensations are powerful, but one nourishes calm curiosity, while the other stirs determination. Gravity also influences water behavior, though Titan's lakes are made of liquid methane and ethane. Low gravity means waves move sluggishly, forming ripples that take minutes to settle. Mars lacks large bodies of liquid entirely. Lakes, seas, and rivers don't exist there today. These differences redefine how humans might conceptualize beauty on each world. Another subtle point emerges in transportation efficiency. On Titan, heavy cargo requires minimal thrust to move. Mars imposes greater fuel consumption due to stronger gravitational pull. Long-term supply chains benefit enormously from Titan's conditions, reducing overall energy costs across decades of settlement. Humans might eventually develop unique architectural aesthetics molded by gravity. Titan's low-gravity domes could stretch taller and smoother, blending into the haze-filled atmosphere. Mars would inspire structures that are compact, fortified, and robust, echoes of frontier towns reshaped by extraterrestrial engineering. Although both worlds challenge human physiology, Titan's gravity reshapes emotion more gently. Its subtle pull becomes part of the sensory experience that defines the world, merging softly with its golden sky and thick air. Mars, with its harsher presence, makes settlers feel part of an ongoing struggle. Gravity becomes a whisper on Titan, a firm reminder on Mars. Ultimately, the gravity of a world shapes not only the physics of living, but the philosophy of belonging. Titan invites creativity, movement, and gentle exploration. Mars inspires resilience, discipline, and endurance. Both worlds reveal who we are, but only Titan lets us drift in a way that feels almost serene. When thinking about the future, the question becomes whether humanity seeks a world that challenges its strength or a world that nurtures its curiosity. Gravity, though invisible, frames the answer. And as we drift forward, another layer of the comparison unfolds, waiting for its turn to guide this cosmic exploration. Air defines how a world feels long before you ever touch its soil. Titan greets you with an atmosphere thicker than Earth's, dense enough to cradle sound, soften movement, and turn every step into something slow and dreamlike. Mars, by contrast, offers almost no air at all. Its atmosphere is thin, sharp, and uncooperative, providing little warmth, little protection, and virtually no pressure. These differences aren't merely technical, they are emotional. One world wraps itself around you, the other forces you to shield yourself constantly. Experiments conducted by NASA's Cassini-Huygens mission revealed that Titan's air is composed primarily of nitrogen with a touch of methane, creating conditions where sound travels gently and visuals appear muted under an amber glow. Mars, on the other hand, exposes explorers to an atmosphere made mostly of carbon dioxide at less than 1% of Earth's pressure. Settlers would require full suits, constant monitoring, and airtight protection at all times. Titan, unexpectedly, feels more forgiving. When you imagine breathing on Titan, it becomes clear that no human can inhale its air without equipment, but the physical pressure itself is comfortable, almost cozy. Walking outside requires insulation and oxygen tanks, yet your body wouldn't suffer from explosive decompression the way it would on Mars. That extra cushion of atmosphere reduces immediate danger. Mars treats human bodies harshly. Without a pressurized suit, death would arrive in less than a minute from suffocation and loss of bodily fluids. Across Titan's horizon, the atmosphere shapes every beam of sunlight into a golden glow. The haze creates a world where nothing feels harsh or sharp. Everything appears softened, like a painting brushed over with a layer of warmth. Mars displays the opposite mood. Its skies are thin and pale, tinted by iron-rich dust that scatters light into a cold salmon color. The red planet seems honest in its exposure, open but unkind. Titan feels secretive, mysterious, almost shy. The presence of thick air on Titan provides another gift, temperature stability. Despite the world being unbelievably cold, colder than anything found naturally on Earth, its dense atmosphere prevents violent temperature swings. Mars cannot offer the same comfort. Its daytime temperatures may reach tolerable levels, but nights plunge into deadly extremes, sometimes lower than the hardest winters on this planet. Human habitats on Mars must endure these daily whiplashes. A thicker atmosphere protects Titan from meteoroids, burning most of them before they ever reach the ground. Mars has no such shield. Impacts remain a real hazard, and colonists must build structures with sturdy roofs and cautious engineering. On Titan, most construction takes place beneath a protective blanket of air. In a poetic twist, the moon farthest from the sun treats visitors more gently than the planet closer to it. Considering flight, Titan becomes an engineer's paradise. The combination of dense air and low gravity makes aerial exploration simple. Drones, airships, and even human-powered wings become practical tools of travel. Mars denies such freedom. With almost no air to push against, machines must expend enormous energy to stay aloft. On Titan, every aircraft becomes a floating lantern. On Mars, it becomes a struggling engine. Temperature remains a defining challenge. Titan's surface sits near 179 degrees Celsius, yet the thick air insulates astronauts, slowing heat loss and preventing catastrophic exposure. Mars seems warm only by comparison, yet its thin atmosphere allows heat to escape instantly. Without specialized suits, survival is impossible. Habitability depends on whether humans prefer a stable, cold blanket or a volatile day, frigid wind. Methane clouds drift slowly across Titan's sky, forming patterns that move like painted strokes. Their behavior is influenced by atmospheric weight and gentle winds. Mars hosts dust devils that swirl violently across plains. These storms reveal the planet's more dramatic personality, a world shaped by dryness and thin atmosphere. Where Titan whispers, Mars shouts. The soft pressure on Titan creates the sensation of presence, a subtle weight that feels grounding even though gravity is light. Mars offers almost no tactile feedback from the air at all. The silence becomes too sharp, the emptiness too complete. Psychologists emphasize that such sensory deprivation strains the human mind over time. Titan, though far colder, might support emotional resilience more effectively. Exploring Titan's thick air also reveals surprising chemistry. UV light from the sun reacts with atmospheric methane, creating organic molecules that drift downward as fine particles. These compounds may have played a role in prebiotic chemistry. Mars lacks this dynamic chemical richness in its air. The red planet's atmosphere is simple, thin and chemically inert compared to Titan's complex haze. Every gust on Titan feels slow, as if time itself moves differently. Wind there pushes gently but persistently, shaping dunes that crawl slowly across the landscape. Mars hosts storms whose winds can reach impressive speeds, yet carry little force due to low atmospheric density. These storms obscure sunlight, block vision, and coat everything in fine red dust. Titan's winds lull, Mars's winds warn. As settlers build long-term homes, the atmosphere becomes part of the rhythm of daily life. Titan's thick haze filters light into warm hues, creating a world where dawn and dusk melt together. Mars has stark transitions, sharp brightness during the day, and sudden cold darkness at night. People living on Mars would feel the rhythms of survival. On Titan, they might feel the rhythms of contemplation. The question of atmospheric comfort sits at the core of long-term habitability. Titan doesn't let you breathe, yet it protects you. Mars offers sunlight but strips away insulation. One world feels like a softly padded cocoon. The other feels like an exposed metal chamber. Human psychology responds to these qualities in ways that remain uncharted but deeply important. Sound behaves differently, too. Titan's atmosphere carries low frequencies well, making footsteps, voices, and tools sound deeper and softer. Conversations might feel like they're taking place underwater, rich and muted. Mars barely carries sound at all. Words become thin, faint, almost lonely. The acoustic character of a world shapes how people experience togetherness. Looking up on Titan means gazing into layers of orange haze. The sun appears as a dim, distant disk, almost shy behind the atmospheric veil. On Mars, the sun sharpens into a small, white bead surrounded by pink dust. One sky feels dreamlike, the other feels alien. Both evoke wonder, but in entirely different directions. Navigation relies on atmosphere as well. Titan's thick air supports long-distance drone mapping. Mars requires orbiters and satellites for consistent surveys. These technological differences shape how quickly settlers can explore, expand, and understand their new world. Titan gives explorers a canvas. Mars gives them a puzzle. Emotionally, Titan's atmosphere feels safer despite its composition. Humans respond to pressure and presence. Being wrapped in dense air, even air you cannot breathe, gives a sense of grounding. Mars offers no such comfort. Its atmosphere feels like a void pressing in from all directions, reminding settlers constantly of fragility. Titan's golden haze becomes part of its identity. It colors memories, moods, and reflections, giving settlers a world where the sky always feels like early morning. Mars paints its world with red dust and pale skies, a palette that inspires determination rather than relaxation. One world calms, the other challenges. When scientists evaluate which world offers better long-term emotional stability, Titan often surprises researchers. Despite the extreme cold, its atmosphere supports a more nurturing sensory environment. Mars demands constant vigilance and engineering. Titan asks for patience and insulation. Each environment shapes the philosophy of those who call it home. As humanity expands across the solar system, atmosphere will be one of the first things settlers learn to read. How it feels, how it moves, how it protects or exposes. Titan's air becomes a quiet companion. Mars's air becomes a stern teacher. And as this comparison deepens, the next layer of habitability invites us forward, guiding the journey into new terrain. Far from the warmth of the sun, worlds behave in unexpected ways. Titan is one of them, a moon that carries its mysteries inward, storing them beneath a shell of ice thicker than any ocean on Earth. Yet beneath that frozen casing, scientists have found convincing signs of a deep, global sea. Liquid water in such a distant place feels almost paradoxical, but the evidence keeps guiding us back to the same quiet truth. Titan hides a world within a world. Cassini's measurements were the turning point. As the probe circled Titan, subtle changes in the moon's rotation betrayed the presence of something moving beneath the surface. Only a liquid layer could explain the way Titan shifted and flexed. Mars, meanwhile, no longer shows such signs. Its ancient waters retreated into isolated pockets, frozen and still, unable to echo with the same internal life. Deep inside Titan, ammonia mixes with water, lowering its freezing point and allowing an ocean to stay liquid even at temperatures colder than anything Mars experiences today. On Mars, droplets of water form only briefly, often mixed with salts, and vanish almost as quickly. Titan's internal sea endures, unfazed by the brutal cold above. Interactions between Titan's rocky core and its hidden ocean may create chemical energy. Hydrothermal vents are possible, places where minerals, heat, and water meet. Earth's deepest ecosystems depend on these same forces. Mars once hosted comparable environments, but its internal heat faded long ago, leaving only quiet reminders in ancient rocks. Temperature stability shapes the fate of these worlds. Titan's layered crust insulates its interior, protecting the ocean from extremes. Mars struggles with dramatic fluctuations between day and night, season to season, pushing its remaining water into inhospitable cycles. Chemistry thrives on consistency, something Titan has quietly preserved for millions of years. Pressure deep inside Titan leads to exotic forms of ice, structures unlike anything found naturally on Earth. These layers trap heat and create boundaries that may influence ocean circulation. Mars lacks such complexity today. Its simpler subsurface environment cannot match Titan's stratified depths and intricate layers. The availability of organic molecules adds another dimension. Titan's surface constantly manufactures complex chemicals through atmospheric reactions fueled by sunlight and Saturn's magnetic environment. Those molecules accumulate, drift downward, and may eventually interact with the liquid ocean. Mars also holds organics, but many have been degraded by radiation over billions of years, leaving fragments instead of building blocks. Gravity shapes these environments gently but decisively. Titan's lower gravity allows deep oceans to form with pressures that rise more gradually than on Earth. Slow-moving currents could distribute energy in patterns that last for ages. Mars, with a stronger gravitational history and a smaller remaining water inventory, supports only shallow, localized activity. Some models suggest Titan's ocean may be hundreds of kilometers deep. If true, it would dwarf Earth's oceans in volume and potential chemical diversity. Mars's water, in comparison, lives tucked into ice caps or trapped beneath layers of regolith, signifying loss rather than abundance. Saturn's influence provides a unique source of internal heat. Each orbit generates tidal forces that knead Titan's interior, preventing complete freezing. Mars no longer benefits from strong external forces. Its orbit and internal structure create little heat. Titan remains active at its core, while Mars grew still. Future missions may reveal even more. Instruments sensitive to subtle vibrations could map Titan's internal layers with precision, unveiling the shape and depth of the hidden sea. Mars missions are already uncovering reservoirs of ice, but these discoveries lack the global, unified nature of Titan's subsurface world. Titan's organic surface compounds create a fascinating cycle. They fall as rain, gather in dunes, dissolve in methane lakes, and potentially migrate downward over long spans of time. Each transition reshapes molecular structures. Mars's organics follow a harsher path, exposed to ultraviolet radiation and oxidizing soil long before reaching protected environments. Circulation within Titan's ocean may create magnetic signatures detectable from orbit. If scientists can observe these patterns, they could map the ocean's movement and composition. Mars exhibits remnant magnetism locked in ancient crust, but no active magnetic system tied to a liquid ocean. Considering life in such environments expands imagination itself. Titan's potential life would operate at temperatures unimaginably low to us. Slow chemistry, long cycles, and unfamiliar solvents would redefine what biology means. Mars's hypothetical life, on the other hand, would likely resemble ancient Earth microbes, stubborn survivors clinging to narrow habitable zones. Even though Titan's ocean lies buried deep below methane rivers and nitrogen fog, its presence shapes everything above it. Fractures, cryovolcanism, and shifts in the crust all whisper stories of movement below. Mars's geological connections to its frozen water stores are faint echoes now, remnants rather than active processes. Water, frozen, liquid, or locked away, tells the histories of these worlds. Titan's story is quiet, concealed, patient. Mars's story is visible, eroded, remembered through landscapes sculpted by flows long gone. Titan invites speculation about the future of chemistry. Mars reminds us of what once might have been. The contrast between these worlds deepens appreciation for both. Titan offers potential, a canvas of slow-moving possibility. Mars offers memory, its surface carved by ancient seas, its atmosphere thinned by time. Each world holds a different lesson about survival and transformation. Thinking about the unknown depths beneath Titan's crust feels like contemplating a dark, silent sanctuary where time loses its meaning. By contrast, Mars whispers through its frozen reservoirs like a museum of planetary history. Titan hints at what could form. Mars testifies to what has already passed. Human exploration may one day reach these hidden places. Robots could swim through Titan's dark ocean, analyzing chemistry never before touched by light. Drills on Mars could uncover frozen archives that hold the signatures of ancient life. Each mission draws us closer to understanding our cosmic neighbors. And as curiosity follows these possibilities deeper, the mind naturally drifts toward another frontier, one shaped by landscapes not of water and rock alone, but of air, sky, and light. Above Titan's frigid surface stretches an atmosphere thicker than Earth's, glowing with a deep orange haze that softens every direction. This blanket of nitrogen and organic compounds shapes the moon's identity so thoroughly that nothing about it resembles the thin, vulnerable air hugged around Mars. Understanding these two worlds begins with recognizing how differently they breathe or struggle to. Titan's atmosphere offers insulation from cosmic radiation, a rarity in the outer solar system. Its density slows falling particles, breaks harmful energy apart, and creates an environment far more forgiving than Mars's exposed landscape. High above the Martian plains, solar radiation pours down unfiltered, striking soil, rock, and any potential life with unrelenting force. Closer to the surface, Titan's atmospheric pressure feels surprisingly familiar. It is about 1.5 times that of Earth's, heavy enough to press gently on the skin but not dangerously so. Mars, by contrast, barely holds on to 1% of Earth's pressure. Water cannot remain liquid there, and even breathing equipment must work harder to compensate for the near vacuum. Chemical reactions in Titan's upper layers create a stunning variety of organic molecules. Sunlight interacts with methane, sculpting new compounds that drift downward in slow cascades, enriching the surface with material that may one day tell us how life could arise. Mars has organics too, but they appear as remnants scarred by radiation rather than products of active atmospheric chemistry. Winds on Titan carry a muted elegance. Their slow movement stirs dunes, carves valleys, and pushes methane clouds across the golden sky. Mars, however, experiences sharp and unpredictable gusts that lift dust into the air, creating storms that swallow entire hemispheres. The fragility of its atmosphere magnifies every disturbance. A layer of stratospheric haze on Titan acts almost like a parasol, deflecting ultraviolet light and protecting the world beneath. Mars lacks this comforting filter. Its surface bears the scars of billions of years of harsh UV exposure, bleaching the soil and breaking down vulnerable compounds before they can evolve. Temperature regulation works differently on these two worlds. Titan's atmosphere traps cold rather than heat, creating stability that lasts through Saturn's long seasons. Mars suffers dramatic swings. Without a thick blanket of air, warmth escapes rapidly at night, plunging the world into icy darkness long after the sun sets. Sound behaves uniquely within Titan's dense atmosphere. Vibrations travel more efficiently, giving every noise a richer, deeper tone. Future explorers might hear their own footsteps in a way impossible on Mars, where thin air mutes even the strongest movements. Environment shapes experience. Atmosphere shapes perception. Cloud systems on Titan reveal the slow dance of methane as it cycles through evaporation, condensation, and rain. Mars once hosted clouds thick enough to shape landscapes, but today only thin wisps drift across its sky, delicate and transient, unable to stitch together a water cycle as complete as Titan's. Saturn's influence interacts with Titan's atmosphere in subtle ways. Charged particles collide with nitrogen, sparking reactions that feed its complex chemistry. Mars answers to no such partner. Its evolution depends solely on its own diminishing energy. A sense of shelter emerges when imagining Titan's skies. The dense air creates an almost cocoon-like environment, reducing the harshness of the cosmos. Mars feels exposed by comparison, its atmosphere too frail to shield anything living from the vacuum of space. The difference between these worlds becomes emotional as well as scientific. Pressure and temperature stability give Titan a surprising advantage in potential human habitats. With proper thermal protection, structures could rely on the atmosphere to bear weight and maintain integrity. Mars habitats must constantly fight against the low pressure threatening to tear them apart. The haze around Titan creates twilight even during the brightest moments. Everything appears dreamlike, softened by layers of drifting particles that filter sunlight into amber tones. Mars's clarity is sharp, unfiltered, and almost metallic, its sky tinted rust red by iron dust rising from the surface. Storm patterns on Titan develop slowly, building over long intervals, offering predictability that explorers could rely on. Mars's dust storms emerge suddenly, swallowing the horizon in minutes and dragging static electricity across the land, a hazard for equipment and humans alike. A curious feature of Titan's atmosphere is its ability to sustain methane rain, drops falling slowly through cold air until they splash into lakes and rivers of liquid hydrocarbons. Mars once had rain, but today only thin carbon dioxide snow falls in isolated regions, a haunting reminder of a warmer past. Sunlight struggles to penetrate Titan's haze, casting the world in a gentle twilight. This dimness would require artificial light for human activity, but it also protects delicate chemistry from destructive radiation. Mars enjoys brighter days, but its exposure comes at a cost: rapid degradation of organic material. Wind erosion shapes Titan in round and flowing forms. Dunes stretch like sleeping animals across the landscape, shaped by gentle atmospheric currents. Martian dunes appear more serrated, sharp-edged, etched by harsher winds that cut rather than sculpt. Electrochemical reactions in Titan's atmosphere continue to surprise researchers. Some compounds resemble the precursors of amino acids, raising questions about whether such chemistry could progress further under the right conditions. Mars's atmosphere cannot replicate this complexity today, though remnants of ancient processes linger in its soil. When imagining life inside habitats on either world, atmospheric support becomes significant. Titan's pressure allows for simpler designs, potentially even open-air balloon structures. Mars requires sealed environments, thick walls, constant pumping, and vigilance against leakage. Sky color defines each world's mood. Titan's soft golds and browns create an atmosphere of quiet mystery. Mars's red dust and thin blue sunsets evoke a sense of isolation. Both are beautiful, but Titan's sky feels gentler, less confrontational, more forgiving. If humans ever learn to fly in Titan's atmosphere, the experience might resemble drifting through heavy, buoyant air. Low gravity and thick skies create conditions where wings or simple mechanical devices could lift a person. Mars cannot offer such experiences. Its thin atmosphere rejects flight except through carefully engineered machinery. The stability of Titan's air extends deep into its climate cycles. Seasonal changes occur slowly, almost meditatively, shaped by Saturn's long orbital period. Mars's seasons shift rapidly, challenging explorers with unpredictable weather patterns that force constant adaptation. Understanding atmospheres helps reveal what makes each world unique. Titan's sky is a world unto itself, layered, reactive, and nurturing in unexpected ways. Mars's air carries history, thin, wounded, shaped by loss more than growth. Both tell stories worth listening to. And as these two environments settle into your imagination, a new curiosity begins to grow, one shaped by the landscapes that stretch beneath those skies and the possibilities they hold. Human beings have always carried a quiet longing to push into places we were never meant to stand. That longing shapes how we imagine life far from Earth, where every breath depends on our own ingenuity. The contrast between Titan and Mars reveals not just scientific differences, but the deeper question of what kind of world best nurtures the human spirit. Safety, comfort, challenge, wonder. Each world offers a different balance. Mars often enters the conversation first because it feels close and familiar. Its reddish surface resembles deserts on Earth. Its landscapes echo the canyons and dunes we already know. For many people, that resemblance creates emotional comfort. Titan, with its alien glow and freezing temperatures, seems intimidating at first glance, as if it belongs to a dream rather than a future settlement. Comfort, however, is only one dimension. Titan's atmospheric protection provides a sense of shielding that Mars cannot replicate. Knowing that radiation levels remain naturally low shapes how humans might feel outdoors, even in bulky suits designed for extreme cold. On Mars, stepping outside a habitat means facing the unfiltered violence of cosmic and solar radiation every single time. The psychology of danger becomes a subtle but persistent factor. Prolonged exposure to high-risk environments can wear down morale, weakening group resilience. Titan's protective atmosphere may offer explorers a calmer baseline, a place where the outside world feels harsh. Yes, but not hostile in every direction. Mars challenges that tranquility as soon as the airlock opens. Light defines mood, and each world paints its own emotional palette. Mars is brighter, with sharp shadows and copper-colored horizons. Titan's light arrives softened by haze, turning landscapes into gentle gradients of golden brown. Living under such muted skies might create a sense of perpetual dusk, calming for some, melancholic for others. The human brain responds deeply to color and brightness. Inside habitats, daily routines would differ drastically. Mars allows ample solar power in many regions, enabling natural rhythms that more closely follow day-night cycles. Titan's weak sunlight complicates this, making communities reliant on nuclear or alternative energy sources. Nights would stretch long, and artificial lighting would shape circadian patterns more than natural cues. Food production becomes another diverging storyline. On Mars, greenhouses could rely on filtered sunlight, pressurized environments, and Earth-like soil mixtures engineered to support plants. Titan would demand closed-loop agricultural systems using artificial light and carefully managed temperatures. Each world forces different kinds of creativity, and each reveals how far humans can stretch their adaptability. Mobility on the surface varies dramatically as well. Mars has gravity around 38% of Earth's, enough to feel familiar while still reducing strain on joints and muscles. Titan's gravity is only 14% of Earth's, creating a sensation closer to floating than walking. Movement there might feel like exploring an underwater dreamscape, slow and deliberate, with the body learning a new definition of balance. Clothing shapes identity, and here the contrast becomes striking. Martian suits must protect against pressure loss, radiation and temperature extremes. They are bulky, rigid, and heavy. Titan suits focus on insulation and thermal control, offering more flexibility because the atmospheric pressure outside helps maintain structural integrity. Human presence on Titan would feel less constrained physically, despite the cold. Noise, or the absence of it, plays a role in emotional well-being. Mars's thin air dampens sound. Footsteps become faint murmurs. Voices lose richness, and machinery hums with a hollow tone. Titan's dense atmosphere deepens every vibration, giving even simple tasks a low, resonant quality. Living there might feel oddly comforting, as though the environment responds gently to every movement. Group dynamics evolve differently depending on external pressures. On Mars, constant danger encourages a pragmatic mindset shaped by caution and routine. Titan's unique chemistry and the shelter of its thick atmosphere might inspire curiosity-driven exploration, inviting teams to gather samples, observe methane rainfall, or drift above the dunes in lightweight vehicles designed to ride the dense air. Isolation affects the mind, and both worlds carry their own versions of loneliness. Mars cars, with its open vistas and unbroken horizons, creates a sense of exposure. Titan, wrapped in haze and twilight, feels enclosed and inward-looking. Some people may thrive in that cocoon-like atmosphere, others may yearn for brighter skies. Choosing a home among the stars becomes unexpectedly personal. The sense of belonging emerges through interaction with the landscape. Martian explorers might bond with its sharp terrain, finding comfort in familiarity despite its dangers. Titan explorers could form attachments through mystery, through slow-moving clouds, reflective lakes of methane, and the towering presence of Saturn overhead. Emotion becomes bound to environment. Energy infrastructure changes how settlements grow. On Mars, solar arrays spread like metallic gardens, capturing sunlight during long stretches of clear skies. Titan requires a different approach, reactors providing steady power regardless of weather or season. Such independence can free human communities from environmental limitations, but it also shapes cultural attitudes toward technology and survival. Communication delays influence human connection to Earth. Mars sits close enough that messages exchange in minutes. Titan, much farther away, creates long pauses between transmissions, seconds stretching into hours depending on orbital positions. Conversations become slower, more thoughtful, more intentional. Patience becomes a way of life. If families eventually form on another world, the atmosphere would shape childhood itself. On Mars, children would grow up under strict rules of exposure and radiation limits. On Titan, the cold would restrict outdoor play, but the protective air might allow freer movement within safe zones. The very concept of outside changes meaning. Art on each world would reflect its landscape. Martian paintings might capture harsh light, jagged mountains, and dust storms swirling in the distance. Titan-inspired artwork could lean into soft gradients, surreal reflections on liquid methane lakes, and the far glow of Saturn. Creativity bends to the colors and textures of new horizons. Time feels different depending on environment. Mars rotates close to Earth's pace, offering days only slightly longer than ours. Titan's slower rotation and distant orbit create elongated cycles. Living there means adopting a rhythm more detached from sunlight and more tied to internal community routines. Safety protocols shift cultural values. Martian life requires constant vigilance, monitoring oxygen, radiation, dust infiltration, structural integrity. Titan demands different priorities: managing heat, preventing equipment from freezing, maintaining energy supplies. Each world builds its own philosophy of survival. Psychological resilience depends on meaningful landscapes. Mars provides clarity and openness, traits that some minds crave. Titan offers mystery, stillness, and depth, qualities that feed introspection. Neither world is universally better. Each nurtures different aspects of human nature. Survival in alien environments reveals unexpected truths about what we value. Titan emphasizes protection and stability. Mars highlights independence and exposure. In both places, humans reinvent themselves day by day, adapting not only to terrain, but to emotional atmospheres shaped by light, sound, and space. And just as one begins to settle into the feel of these worlds, another possibility emerges. Hidden beneath ice, drifting in deep oceans, waiting to expand the story of where human life could someday unfold. Far beneath Titan's frozen crust lies a world entirely unlike the one above it. A shadowed ocean stretching for hundreds of kilometers, warmed by tidal forces and chemical reactions that never see the light of Saturn. This hidden ocean has become one of the most intriguing mysteries in planetary science, a place where liquid water may flow in total darkness, sheltered from the violent emptiness of space. Researchers first suspected this subsurface ocean by observing Titan's rotation. Subtle wobbles detected by NASA's Cassini spacecraft hinted at a decoupled outer shell, as if the icy surface floated atop a deeper, mobile layer. Patterns in Titan's gravity field reinforced the idea. Something fluid was shifting far below, slowing and redirecting the moon's movements in ways only an internal ocean could explain. Chemical evidence adds another dimension. Titan's surface contains complex organic molecules that fall like snow, created high in its atmosphere by ultraviolet light. Over millions of years, those organics sink through cracks and fractures, potentially reaching the ocean below. When carbon-rich material meets warm water, the chemistry becomes enticingly similar to what early Earth experienced. Scientists studying Titan often point to hydrothermal activity as a possible energy source. Saturn's gravitational pull stretches the moon slightly, generating heat deep inside. This process could warm portions of the ocean, creating gradients where organic chemistry thrives. Life on Earth depends on energy differences, and Titan may host them naturally. The thickness of Titan's crust plays a crucial role in this hidden world. Some regions appear rigid, while others appear flexible and fractured. If cracks connect the surface to the ocean, material exchange becomes possible. That movement could deliver nutrients downward and carry dissolved compounds upward, creating a slow but meaningful cycle. Pressure within Titan's ocean would be immense. Water trapped beneath kilometers of ice is squeezed by gravity into dense layers, potentially forming exotic phases of ice. Yet even under pressure, some regions may remain warm enough for liquid pockets to persist. Life on Earth survives in similar environments, under Antarctic ice shelves, in deep-sea vents, and within pressurized lakes sealed for millions of years. Methane lakes on the surface introduce another possibility. As liquid methane seeps through porous layers, it may transport organic compounds downward. Over geological timescales, this mixing could deliver a constant supply of carbon-based molecules to the ocean, feeding reactions that would otherwise stagnate in extreme cold. Models from JPL and European research groups suggest the ocean could contain ammonia, a substance that lowers water's freezing point and stabilizes liquid environments. Ammonia-rich oceans may sound toxic, but they open doors to alternative biochemistries, perhaps not life as we know it, but life adapted to conditions unlike anything on Earth. Clathrate structures might form at the boundary between ice and liquid water, trapping methane or nitrogen within crystalline cages. These structures could influence ocean circulation, storing or releasing gases slowly. the interplay of clathrates, salt content, and internal heat shapes patterns that scientists are only beginning to predict. Imagining movement within Titan's ocean evokes a world of slow currents drifting through dim, bluish water. No sunlight penetrates that depth, so any life would rely on chemical energy rather than photosynthesis. On Earth, microbes flourish in similar environments, feeding on minerals rising from volcanic vents. Titan may host comparable reactions fueled by serpentinization, a process where rock and water generate hydrogen. The mystery deepens when considering how long Titan's ocean has existed. Geological models imply it could have persisted for billions of years, perhaps even longer than Earth's oceans. Longevity matters. Time allows chemistry to explore possibilities, forming stable patterns that gradually evolve toward complexity. If biology exists there, it would likely be microbial, simple but resilient, thriving in comforting stability. Yet even simple microbes hold profound implications. Their existence would demonstrate that life does not require sunlight or Earth-like conditions, only a suitable environment, energy, and time. Titan may quietly hold all three. Communication between the subsurface ocean and surface geology influences how scientists evaluate habitability. A fully sealed ocean might remain chemically isolated, limiting biological potential. But an ocean connected through fractures, plumes, or upwellings could encourage ongoing exchange, renewing chemical gradients that sustain lifelike reactions. The sediment of Titan's ocean, if it exists, could contain precursor molecules layered over immense time. These sediments might form a historical record far richer than anything accessible on the surface. Cassini hinted at possibilities but could not confirm them. Future missions may one day drill, melt, or swim into these depths. Thinking about exploration invites a blend of wonder and caution. A probe entering Titan's ocean would encounter pressures similar to Earth's deepest trenches. Its instruments would need to endure crushing forces while analyzing chemistry in real time. Yet the reward could be extraordinary. The first glimpse of an alien ocean untouched for billions of years. If humans eventually build bases on Titan's surface, curiosity about what lies below could become a defining cultural element. Generations might live their entire lives atop a world, hiding something extraordinary just beneath their feet. That knowledge alone shapes imagination, identity, and the way future explorers understand their place in the cosmos. The presence of a subsurface ocean challenges the idea that Titan is simply a cold outpost. Instead, it becomes a world layered with depth, haze above, methane seas at the surface, ice structures beneath, and a vast reservoir of liquid water even deeper. Each layer supports its own form of complexity. Earth's ocean worlds, Antarctica, Greenland, deep crustal aquifers, serve as mirrors for Titan's potential. Life thrives in places once thought sterile. Microbes lurk in rock fractures kilometers below land, persistent and adaptable. Extremophiles show us that biology finds ways to flourish where intuition fails. Considering the possibility of life on Titan encourages introspection. Humanity tends to place itself at the center of significance, but the universe may tell a different story. Tiny, unseen forms could be thriving on a world saturated with cold and darkness, proving that existence takes root wherever the environment allows. Researchers sometimes describe Titan's ocean as a time capsule. Unlike Earth's oceans, which constantly churn and recycle, Titan's may preserve ancient conditions. If true, it could hold clues about how chemistry first learned to imitate life, even if it has not crossed the threshold into full biological complexity. The thought of two oceans, one open to the sky and one hidden in the dark, enriches Titan's identity. At the surface, methane cycles offer familiar patterns in unfamiliar substances. Below, the subsurface ocean holds secrets locked behind ice, waiting for the right tools and patience to uncover them. Each world teaches something different. Mars teaches endurance. Titan teaches subtlety. Mars offers clarity in its barren landscapes. Titan offers mystery layered within mystery. Choosing between them requires more than engineering. It requires deciding what kind of future humanity envisions. And as your mind drifts through the possibility of an ocean beneath a haze-covered moon, new questions gather in the quiet. Some belong to chemistry, some to geology, and some to the inner places where imagination meets science. Something deeper begins calling, a question shaped by distance, energy, and the strange ways alien worlds store their secrets. Awareness of Titan's distant landscape has a way of turning introspective, as if the moon's haze reflects something hidden within us. When scientists study its thick atmosphere or its slow-moving rivers of methane, they're not just searching for habitability, they're searching for perspective, a sense of who we are in a universe that easily outlives every civilization we build. Choosing between Mars and Titan becomes more than a technical debate. It becomes a mirror held up to humanity's hopes and anxieties. Mars represents urgency, raw rock, harsh winds, and the need to force life to fit. Titan represents patience, a world where everything moves slowly, waiting for the right moment. Each world echoes a different aspect of ourselves. Space agencies often describe exploration as a practical mission: gather data, build technology, advance knowledge, yet beneath those objectives lies something deeper and quieter. Humans seek meaning across distance, hoping that extremity might reveal truths we struggle to see at home. Titan, with its dim golden light and secretive ocean, invites that kind of reflection. The contrast between Earth's familiarity and Titan's strangeness highlights how fragile our sense of belonging really is. We tie identity to landscapes, colors, and rhythms of daylight. Titan dismantles all of those anchors. Its sky glows orange, its rivers are cold hydrocarbons, and sunlight barely reaches its surface. Existing there would demand a redefinition of what home means. Psychologists observing astronauts note how isolation sharpens introspection. On Titan suit, isolation becomes a planetary feature, a quiet so profound it might shape the human mind in new ways. People raised beneath its gentle twilight could develop a sense of time slower than ours, influenced by a day that lasts over 16 Earth days and seasons spanning 29 years. Imagining those future lives feels strangely tender. Children born inside Titan habitats might never see an open blue sky. Instead, they would grow up watching artificial lights on domed ceilings and hearing stories about Earth the way ancient cultures heard myths about lost continents. What we call normal would be a legend to them. Titan forces us to appreciate Earth in ways that statistics alone cannot. When you picture its -180-degree sea surface, or its dense haze that hides Saturn except during rare clearings, you sense the privilege of warmth, of oceans that sparkle, of rain made of water instead of methane. The strangeness of another world becomes a quiet homage to our own, but reflection doesn't end with gratitude. Titan also expands imagination. It challenges assumptions about where life can emerge, thrive, or adapt. If chemistry on Titan eventually proves capable of organizing itself, humanity would confront the humbling truth that we are not an exception, only one expression among many cosmic possibilities. Scientists often speak of habitability, yet the word carries emotional weight when you imagine humans actually living there. Habitability is not just liquid water, stable temperatures, or protective atmospheres. It is the ability to feel belonging. On Titan, belonging would need to be recreated through community, ritual, art, and the soft resilience of those who dare to call it home. Some philosophers argue that exploring distant worlds is a form of self-exploration. Titan supports that view. The moon's silence reveals how much of our identity relies on sound, birds, oceans, wind in trees. On Titan, sound travels slowly and softly, shaped by its thick air. Voices would be lower, footsteps quieter, conversations almost whisper-like. Identity itself would change. The memory of Earth would remain powerful. Migrants living on Titan might dream of forests they never walked in, oceans they never swam in, or skies they never saw. Memory would become a cultural inheritance rather than a personal experience. And that inheritance would shape how Titan's settlers understand themselves as descendants of two worlds. In such a distant place, even human conflict might shift. Scarcity would be different. Priorities would change. Life would revolve around cooperation, scientific curiosity, and patient survival rather than the rapid cycles of Earth's economies. Titan's slow rhythm might influence human society toward introspection instead of urgency. Yet despite the moon's strangeness, something universal remains. Wherever humans gather, we create warmth in stories, meals, friendships, and rituals. Imagining families sharing meals inside Titan habitats, or scientists celebrating milestones beneath Saturn's muted glow, emphasizes how adaptable we truly are. Humanity carries home within itself. Titan also tests the boundaries of ambition. Every dream of colonization echoes a deeper question: how far should humanity go? Some argue that expanding to other worlds is our destiny, that survival depends on multiplying across the cosmos. Others believe that such expansion distracts from preserving our original home. Titan quietly asks both groups to rethink their convictions. You can sense the emotional gravity in these debates. Hope on one side, caution on the other. Exploring Titan becomes a meditation on balance, progress without recklessness, imagination without escapism, resilience without detachment from Earth. The moon's quiet beauty softens extremes, encouraging a contemplative middle ground. One of the most moving ideas in planetary science is the concept of cosmic loyalty. It refers to the emotional bond linking people to their home world. Earth's gravity has a metaphorical version. It pulls at the heart. On Titan, that pull would remain, shaping the culture of settlers who carry stories of two worlds, never forgetting where their lineage began. As Titan's mysteries unfold, humanity confronts its own limitations. We cannot breathe its air. We cannot walk outside without layers of protection. We cannot see the sun clearly. This vulnerability is both frightening and strangely comforting. It reveals that existence anywhere beyond Earth requires humility, a trait our species often forgets. The moon's slow cycles mirror the arc of human life: long winters, gentle summers, and rhythms stretched across decades invite patience. People living there might measure time through generations rather than weeks. This expanded sense of time could change how humanity thinks about responsibility, legacy, and the meaning of the future. The possibility of life in Titan's ocean deepens existential wonder. If biology thrives there, even at a microscopic scale, it means we share the universe with neighbors who evolved in total darkness. Their existence would gently reshape human philosophy, transforming loneliness into connectedness, isolation into kinship. Contemplating these potentials invites a tender melancholia, not sadness, but a recognition of impermanence. Our civilizations rise and fall, yet the universe remains patient, holding worlds like Titan unchanged for millions of years. Thinking about that timescale offers perspective, softening worries that feel overwhelming on Earth. What humanity chooses to do with Titan's discovery becomes part of a larger story. We stand between two futures, remain bound to one world or stretch carefully outward. Titan doesn't force an answer. Instead, it offers quiet clarity, like a lantern shimmering through fog, illuminating possibilities without demanding a direction. The more we learn about Titan, the more we realize how intertwined exploration and emotion can be. Studying the moon's haze teaches us about chemistry, but also about mystery. Studying its ocean teaches us about physics, but also about longing. Titan becomes a place where science and introspection meet gently. As thoughts drift through these possibilities, Titan ceases to be just a distant moon. It becomes an invitation to imagine who we could be in the future, wiser, slower, more thoughtful, shaped by worlds that challenge our assumptions in the softest ways. Something about Titan calls not to our ambition, but to our curiosity and quiet courage. And with that lingering sense of inward gaze, the journey continues deeper, guided by wonder, humility, and the faint glow of Saturn's distant light. Some questions don't need sharp answers to carry meaning, and the comparison between Titan and Mars belongs to that gentle category. Both worlds reveal different truths about humanity, highlighting our desires, our fears, and the paths we might take. Thinking about them side by side becomes less about choosing a destination and more about understanding what we value in a home. Mars speaks to boldness. Its thin atmosphere, dust storms, and freezing nights remind humanity of its resilience. Settling there would require relentless engineering and unwavering discipline. The red planet seems to ask whether we're capable of shaping a harsh world into something livable through determination alone. Titan, in contrast, whispers instead of challenges. Its thick atmosphere, chemical richness, and protective haze create an environment that feels patient, almost contemplative. Though its cold is severe and its air incompatible with life as we know it, something about Titan feels gentler, not easier, just more forgiving, more open to interpretation. Scientists evaluating the two worlds often draw charts comparing radiation, temperatures, gravity, and resources. Those charts paint Mars as more immediately accessible and Titan as more chemically promising. Yet beneath all the technical contrasts lies a shared truth. Neither world is easy. Both stretch the boundaries of imagination and engineering. Even so, Titan offers a rare distinction, an atmosphere that protects. This alone shifts the possibilities. Human structures could thrive beneath its dense orange sky without constant bombardment by radiation. The moon's natural shield becomes a symbolic gesture, a place that, despite its harsh cold, seems willing to hold life safely if treated with respect. Mars demands strength. Titan encourages patience. The red planet expects settlers to confront danger head-on, while Titan invites them to adapt quietly to cycles slower than their own. Each world embodies a different philosophy of survival. Choosing between them becomes an expression of who humanity wants to be. One remarkable feature of Titan is its potential for long-term sustainability. Methane lakes, organic molecules, and a stable atmosphere provide a foundation that could support industries, energy systems, and perhaps biological adaptations we don't yet understand. Titan may not be Earth-like, but it might be future-like, a glimpse of what humanity could evolve into. Mars, however, offers visibility. You can look up and see a sun that resembles the familiar. You can see Earth as a faint star. Time moves at a rhythm close to ours. These details matter emotionally. A place doesn't become home through resources alone. It becomes home through familiarity, through echoes of the world that shaped us. That emotional dimension raises an important question. Does belonging depend on similarity or possibility? Mars resembles Earth more, but Titan holds more raw material for reinvention. These opposing qualities make the comparison deeper than a debate about colonization. It's a meditation on identity. Some philosophers describe Titan as a canvas world, a place where humanity could design ways of living that differ dramatically from Earth-based norms. Its distant location, slow seasons, and thick skies could inspire new cultural rhythms. Life there might feel less hurried, more reflective, shaped by cycles that unfold over generations instead of months. By contrast, Mars resembles a frontier, rough, urgent, demanding constant attention. Its challenges would keep settlers focused and alert, much like pioneers navigating dangerous terrain. The intensity of such a lifestyle has appeal for those who see progress as struggle rather than contemplation. NASA's long-term plans reflect this duality. Mars remains the primary target for early human missions due to distance and logistical feasibility. Titan occupies a later stage of dreaming, far, slow, patient. Yet every time new data arrives from Cassini, Huygens, or future missions like Dragonfly, Titan grows more enticing. Dragonfly, the nuclear-powered rotorcraft scheduled to explore Titan's surface later this decade, symbolizes humanity's gentle curiosity about the moon. It won't bring settlers or grand machinery. Instead, it will drift through Titan's twilight, sampling chemistry and decoding mysteries. Its mission feels almost poetic, exploration at the pace of thought. As humanity contemplates future homes, Titan's underground ocean becomes another point of fascination. Water hidden beneath ice suggests geological activity and chemical richness. If life developed there, even microbial, slow, alien, it would transform everything we believe about habitability. The moon would no longer be just a candidate for settlement. It would be a living world deserving protection and respect. Mars lacks that mystery. Its ancient rivers ran dry ages ago. If life existed there, it may remain fossilized or buried. Mars tells a story of endings, Titan, a story of beginnings. This contrast shapes emotional responses to both worlds, one nostalgic, the other hopeful. Yet the choice between them doesn't need to be exclusive. Humanity has always expanded in multiple directions when curiosity allowed. Mars might become the first outpost of raw human ambition. Titan might become the sanctuary of slow science, patient exploration, and deep reflection. Together, they form complementary visions of our future. In considering which world is better, the answer changes depending on the values we prioritize. If speed and proximity matter, Mars wins. If atmospheric safety and chemical potential matter, Titan leads. If emotional resilience is the priority, the answer becomes subjective, shaped by the type of society we want to build. Settling Titan would require a shift in mindset toward endurance and long-term thinking. People living there would plan not in years but in decades. Their culture would reflect Saturn's immense seasons, encouraging patience and collaboration. Mars settlers, meanwhile, would develop a culture of rapid adaptation and grit. These differences highlight a comforting truth. Humanity is diverse enough for both paths. Some dream of forging forward despite difficulty. Others dream of understanding deeply before acting. Titan welcomes the latter. Mars embraces the former. Both dreams are valid. As you consider these possibilities, the comparison reveals something more profound than a ranking of worlds. It becomes a story about humanity learning to understand itself across cosmic distance. Our desires, fears, ambitions, and vulnerabilities all become clearer when reflected through alien landscapes. Titan teaches gentleness, Mars teaches courage. Earth teaches belonging. Together, they form a triad of lessons about who we are, who we might become, and where we choose to grow next. Each world calls to a different part of the human spirit, and somewhere within those calls, a quiet answer forms, not one of preference but one of readiness. As the thoughts settle, the horizon widens. Titan waits in its golden haze. Mars glows red in the dark. Humanity remains at the threshold, imagining futures shaped by worlds we have only just begun to understand. Without rushing, the journey drifts onward, guided by curiosity, humility, and the gentle pull of places that remind us how vast and varied the universe can be. Moments like this feel almost suspended in time, where the rush of questions finally softens, and what remains is a gentle understanding of everything we've drifted through. Titan, Mars, Earth, and the distant worlds that fill our imagination start to feel less like separate places and more like mirrors of human possibility. When we look toward Titan's golden skies or Mars's rust-red valleys, we aren't just observing landscapes, we're observing the many futures we could inhabit. Thinking about Titan after such a long journey brings a sense of calm clarity. Its smoggy light, its sleeping dunes, its methane rivers glowing under Saturn's shadow. All of it creates a world that asks more from our imagination than from our strength. Mars pushes us forward, Titan slows us down. Somewhere in the contrast between these worlds, a deeper part of us recognizes that home is not only defined by comfort or danger, but by the rhythm we choose to live by. Humanity has always existed between two instincts, the drive to conquer and the desire to understand. Mars embodies the first, Titan embodies the second. Our fascination with both reveals something beautiful. We are complex enough to dream in multiple directions, patient enough to explore slowly, brave enough to step beyond the familiar, and wise enough to notice which dreams resonate the most when the universe grows quiet around us. Looking back at the discoveries, theories, and hopes tied to Titan, the moon begins to feel less like a faraway destination and more like a long, slow conversation with the cosmos. Its chemistry, its atmosphere, and its stillness form a reminder that not all mysteries are meant to be solved immediately. Some are meant to be lived with, contemplated gently, like a story meant for generations rather than a single lifetime. And maybe that's what makes Titan so compelling. It doesn't promise rapid progress or quick victories. It offers continuity, a place where human curiosity could stretch itself across centuries, a place where each step, each experiment, each new structure built beneath its orange sky becomes part of a longer arc of understanding. A world where humanity could practice patience on a cosmic scale. As you settle into the stillness of this moment, the idea of better becomes softer, less defined. Titan isn't necessarily superior to Mars, nor is Mars inherently more fitting than Titan. Each world has its own lessons, its own challenges, its own quiet invitation. What truly matters is the mindset we bring with us, whether we seek intensity or introspection, speed or endurance, familiarity or reinvention. Even across billions of kilometers, these places help us understand ourselves. Titan shows how gently a world can cradle potential. Mars shows how fiercely a world can test commitment. Earth shows how deeply a world can be loved. Together, they remind us that our cosmic story is still beginning, still unfolding, still open to countless futures written in ice, dust, light, and time. If this long and quiet journey brought you peace, reflection, or even a moment of wonder, I'm truly grateful you spent it here. And if these calm explorations help you unwind at the end of your day, feel welcome to leave a like and subscribe to the channel. It helps others discover this peaceful corner of the universe as well. Before you drift off, Tell me in the comments where you are watching from tonight and what time it is. As the last thoughts settle, imagine the soft glow of Titan's sky relaxing into silence. In that quiet, remember that your presence, your attention, your curiosity, your stillness shines like a small, steady light on a distant shore. And wherever you are, under whatever sky you're resting tonight, you belong here.